Welcome everyone to this webinar from Simumatik. We are bringing today some inspiration for teachers, for anyone that is working from vocational education, high schools to universities, and telling you what you can do with virtual labs, how you can explore new opportunities, improve your learning content using virtual labs together with your already existing course materials. So before we start, I'm going to present myself. My name is Mikel Ayani. I'm the founder of Simumatik. My background is in automation engineering. I've been working for industry many years, over 20 years, but also teaching for the university and vocational education almost 10 years. So I'm bringing you some experience and some of my background with this webinar. At any time, if you have any question, feel free to write us some comments. My friends here behind the cameras are gonna tell me, and I'm gonna try to answer any question. So we are gonna have a quite hands-on webinar. We are gonna start with a quick introduction, what is Simumatik for those that are new with Simumatik, and then I'm gonna show you some samples or use cases around virtual labs in education. And then we are gonna build some lab together. Actually, we are gonna do some simple lab, but then we are gonna jump and create some lab that we can control with a PLC. So that's gonna be today. It's 6 o'clock here in Sweden. Welcome everyone. I see people from around the world, so let's go ahead. So for those that are new at Simumatik, what is Simumatik? It's what we call a emulation platform, but we like to call it like the Minecraft for engineers. So what we provide is a platform where our users can basically create whatever they can imagine. They digitalize hardware. Okay, what is that hardware? It's equipment, industrial equipment or lab equipment they may have in their institutions, in their schools. We help them to virtualize that, but also we want to provide access to technology to people that maybe, or students that cannot afford it. And we want to provide flexibility. Okay, so with Simumatik, we will provide a tool. We want to democratize the use of technology and bring opportunities to teachers in this new area where digital tools are needed more than ever. So what's the kind of pains that Simumatik can help you release? So with virtual labs, basically what we are trying to provide is a way where students do not need to just use physical labs to do their practices or exercises or whatever. They will be able to use virtual labs all together in parallel, so you don't have to have queue systems and be limited to just equipment you have in your institution. We want also to allow some flexibility to your students, so they can even do their practices or exercise from home or wherever they are. Okay, so we try to complement, or the goal with Simumatik and the virtual models is to complement the actual course content you have, allowing teachers to have more practices and maybe even, as we will see now, adding new technology that they don't have access to, and even allowing the students to play with a little bit of creativity. Okay, so we will go now, or I will show you now some short videos just to give you an idea how these virtual labs can look like. So I'm gonna share my screen and I'm gonna show you a few videos. This is just an example we are using in, or one of the customers is using, where just creating some simple labs with basic instruments or basic equipment. This kind of virtual lab can support basic engineering teaching like physics, mathematics, or how in this case it's a virtual lab around pneumatics. So it's different kind of pneumatic components, pilot, solenoid, manual valves, connected to different kind of cylinders. So in this case, what this kind of lab can support is helping students to understand really what they have been learning in theoretical lessons with their teacher and put in practice what they have learned. So maybe teachers can provide this kind of labs where students need to do just some connection and have a hands-on opportunity with these kind of components. Going further, once the students are familiar with industrial equipment or automatic equipment, then they can start programming these kind of labs. And this video shows actually is one of our tutorials where teachers can use this existing lab to support the PLC programming courses where the students can try to program this system using their actual tools. So Simumatik is not replacing actually the PLC programming tools or anyhow, what we are replacing is actually the hardware. So teachers will be able to use their actual course material, the software they are using to teach PLC programming, but instead of requiring hardware for each of their students, they are going to be using virtual labs to teach PLC programming, any language or whatever, sequential programming or whatever. And when I'm saying PLC, is the same. Basically, this can be extrapolated to robots, as we will see later. And that can be achieved with, we could say, fictitious virtual labs, but one step further is to try to virtualize existing labs in your organization as a teacher. So you may have some physical labs that you use for your students to do some practices or examinations. Providing them a virtual copy of that lab will give you a lot of flexibility. Your students will be able to do most of the effort independently of the physical hardware in parallel, so they will have access, much more access to these labs to do a much better work without having to care breaking stuff or breaking the equipment, and then they will be able to actually demonstrate what they have achieved using their programs they have developed against the real one. So what we are seeing here is actually physical lab that has been virtualized in the, as we see in the video, and it looks and behaves exactly as the real one. And the last one, and what I have learned in all the years I've been working as a teacher, is that this kind of tool, like Simumatik, where you can create your own labs, brings the opportunity to explore new areas, explore new technology, explore new components that you may not have actually access to in your institution. So it offers you the opportunity to tell your students also to explore and build their own system. So what I'm showing you is just some screenshots of an exercise actually that I provide the last course I was giving to some students, where they have to program that system you can see in the picture. It's just a little universal robot with a PLC, and I told them program it, but when you finish, just add some extra equipment and show what you can come up with. And it was really interesting to see the results, how they can actually come up and maybe add new robots, add more conveyors or whatever, and explore their capabilities, explore how much they can program, and so on. So this was just to give you some inspiration, some ideas, what can be achieved with Simumatik, which kind of labs our customers are using right now, and which is the kind of use you can make of these labs. But what we are gonna do now is to just jump into the platform and start building something. Okay, so I'm gonna share again the screen, and I'm gonna show you basically how we can start from scratch. So this is my friend John Doe, just an account we have for these demonstrations. And once you log into our platform, you can select to go just by yourself with your individual account or jump into an organization. Okay, when you purchase a subscription for an organization, you will have, as a teacher, access to administrate this organization and provide different seats to your students. So then when they access the platform, they will see, like in this case, the California University, and they will be able to jump there and see all the labs that you have created for them. So once you do that, then you can decide to run the models locally or online. We are not covering that in this webinar, but basically I'm gonna jump into what it is, our workspace, okay? And for those that are totally new in Simumatik, this workspace is where the things happen, okay? This is where you build your systems or open existing systems, and you can modify them or play with them. So it's just a 3D environment where you can easily navigate with your mouse. And what we are gonna do is just, I'm gonna simply open one of our tutorial systems just to show you how you could start or which are the basics of the platform, how systems are actually built. And then we are gonna use the easiest approach actually to build your own labs. And this approach is taking something that is already built and making a clone or making it your own and keep it building from there, okay? So what we are gonna do is just access to the library of systems, and we are gonna select the public systems, and I'm gonna take this pneumatic tutorial that we have created. These tutorials, all the documentation and the guidelines for the tutorial, you can access them anytime from the clicking here in the help button. So it will bring you, the help button will bring you to the user manual, and here in the lower part you will see how we have all these basic tutorials, PLC tutorials. Feel free to navigate and check all this material. What we are gonna, well, what I'm opening actually is this pneumatic tutorial. So how does Simumatik work? I say you can build pretty much anything you can imagine, but how you build it? Simumatik uses one approach which is called component-based modeling, which means that each component is modeled individually, digitized individually, and then it's uploaded to the cloud, because this is a cloud platform. So when you build a system, what you are basically doing is just taking components that have been previously created and putting them in what we call a system, and then making connections between the components as you do in reality, okay? And this is what we have here. We have just a few pneumatic valves. We have hidden here behind the box the compressor and just a single acting and double acting cylinder. How is this built? We have the system here, we have the assembly, and then we have all these components, each of them with their name. We can click on them and it's gonna be selected here. Each component can be moved independently. We can add more components, as you will see later. And basically, once you have the components in place, you just need to click play and start interacting with them to see what happens, okay? And just a virtual lab can be this example, this tutorial. It can be a virtual lab where you can ask your students, okay, create this functionality. This is the equipment you have. I want you to make the connections that are required with what you have learned in the class, and make this cylinder, for example, move forward or extend when you press this button. And this is the kind of exercise you can ask or you can build for your students. And in that case, the students will need to select the components and then start making the connection. So it's pretty simple. Each component has its information. You can just click here and you can read basically what this component is, which are these connections, and you can actually check its symbol and what the name of each port. And then down here is where you do the connections. So right now, if we want this cylinder to extend, we just need to take the compressor and take its output and connect it to the cylinder. So this is basically what you can do here. We select the compressor output, click play, and then the system or our emulation engine will make the cylinder expand. Instead of connecting the cylinder directly to the compressor, if we put this valve between them. So we connect the valve to the compressor instead. And now we connect the cylinder to the valve, removing the previous connection. Then we can make the valve expand when we press this manual button. Okay, and that's how it works. It's what we are always telling is that if you can build the system in reality, you should be able to build it in Simumatik because of this component-based approach. So, as I mentioned before, the easiest way to build your own labs as a teacher, because what we are offering with all these tutorials is basically some inspiration for you, is just take one that you like and then jump into the system page and make a clone for yourself. And this is gonna be a copy of that public system that in this case we have created, which is gonna be stored in your organization. So we could call it lab Pneumatics. Yep. And it will be stored inside our system. So we can close this now. And now we can go to our systems, and we will see here that we have the Pneumatics lab. And from here, we can now actually add more equipment, add more instruments, and build our own lab. So how you can do that? You can just take components that already exist and duplicate them, for example. So now we have 2 cylinders, and we could change the 2 single acting cylinders, and we could change the name of this one, for example, and put it wherever we want. Or we could go to the library, component library, and check if we have components created by ourselves, or we can go and browse public components and find, maybe in this case, some more pneumatic components. So we can come here and just check which are other pneumatic components in the library, select one, we can read the information and just give it a name. Let's call it valve 4, and just move it somewhere so the students or whoever is going to use the lab can see it and then make the connections. So this is basically the easiest way to start creating your lab, just based on previous or existing systems. You just need to click here to upload and save it. You can also take a capture and take a new snapshot of the or thumbnail for the lab. So when your students will browse it, they will see this new picture. And even if you want to provide them with more information, then you can click in edit, and here you can add more, add the instructions for your lab. You can add some keywords. You can also upload. You have a video. If you have, I don't know, some documents you want to provide, like drawings or whatever for them, so they can create or replicate those drawings in this case. And everything will be stored in the cloud, and whoever has a seat in the organization, wherever it is gonna get access to this content as soon as you save and upload it. So now let's go ahead and create our own lab. It's not gonna be super complicated, so don't expect to be most advanced lab, but we are gonna just make some basic, use some basic components, and then we are gonna show how we can automatize the system we are gonna build. So the most important thing when you are gonna build your lab is that you think about which are the components or the elements you are gonna use in your lab. This is like going shopping and buying your ingredients, all the ingredients you need for your recipe. Okay, so the first thing you need to go to this, or we'd recommend to go to the libraries, create your own library, and start drag and dropping components that you are expecting to use when you are creating. Why? Because it may be a lot of components that you don't need, and this will easy a lot your work while building, and also help your students when you tell them maybe build some new system, but just use the components, for example, included in this library I have created for you. So let's create a demo library. And now what we can do is, of course, if we have our own components, which is not the case because we haven't created anything in this organization, you can add your own components, or you can go to the public library or the public repository and just start grabbing components that you are interested in. And you can just browse them, go page by page, and select the components you want to add, just clicking by the plus button. You can take whatever you want, or you can just, if you are looking for something specific like a push button, then you can filter the elements and just take the one you are interested in. Okay, so this is what we recommend. That as you will see now, it eases a lot the building process because you won't need all the components that are available in the public repository. So just for the exercise, I already prepared this library where I got some little products, some DC motors, some motor contactors, a little conveyor. So we are going to play a little bit with the electrical elements. And then I also added a compressor, a cylinder, and a valve. So we are also going to build, complement the system with some pneumatics, and then we are going to put everything together. So we can go back to the workspace, and now I'm going to create a new system. Let's call it demo lab. And just doing that, the lab will be available now for anyone. We haven't added anything, we haven't uploaded any change, so it's an empty lab. But just so you understand that this is just available now for anyone in the organization. And how you build the system is creating assemblies, which basically is a group of components, and then adding components to that assembly. This is the approach. Is quite used within the mechanical engineers, so we are following that idea. Once you create an assembly, you give it the name you want. So I could just rename it and call it, let's call it general assembly. And we are gonna add here, just to start with something, we are gonna go to my libraries, select my library, the one I had prepared before, and let's add compressor. Let's call it, I like to use short names so it makes much easier to make the connections. So I'm gonna call it comp 01, and now I'm gonna add the power supply. So here it is, we call it power 01. So those are gonna be our general elements for the system. We can now, as you see, select each of the components and move them independently, or if I want to move away for now this group, I can just select the group here and just drag it away. So now let's start creating a simple mini conveyor system. We are gonna call it conveyor. And let's include that mini conveyor we have here. Let's clean this filter, and we are gonna call it comb 01. We need something to move this conveyor, so we are gonna add a motor. Here we have. We are gonna activate the motor with a power supply. As you see, everything is a component in Simumatik, so you require the same equipment as you require in reality to make this system work. So let's find this motor contactor. We call it cont 01. So now we have the motor contactor. Let's put everything nicely in its place. We can move with these arrows, and then we can also rotate the elements. We select the rotation tool. We can always position all the elements manually with the arrows, or just type in a number here in the helper. So now I'm gonna rotate it just exactly 90 degrees. And now we can move it closer. Let's put it somewhere here. Nice. And we do the same with the contactor. We bring it here close to the motor. We rotate it. So what we need to activate the conveyor is we need to set 24 volts in the motor contactor to activate it, to close it, and then connect the motor contactor to the motor, which will be connected to the conveyor. So those are the electrical connections we need to do. But now what I'm gonna make is I'm gonna take a button and I want to activate the conveyor just when I press the button. So let's call this the button 01. Bring it here, rotate it so we have nice access to it. Okay, and now let's do the connections as we did before with the pneumatics. Now we are gonna make them with the electrical ports. So what we need to do, let's start with the button. Let's bring 24 volts from the power supply that we just added. Go to the power supply, take the positive port. Again, if you want to know what is the meaning or what each port does, you can always click on the symbol and check. So we bring 24 volts to the button, and now we connect the button to the motor contactor. We have the symbol here as well. I know that we need to connect to activate the contactor forward movement. We need to set 24 volts in X11 and 12. So let's take the output of the button and the power supply 0 to the X12. Now we just need to feed the motor contactor. So let's put 24 volts between X1 and X2. And basically now what we need is to connect the motor to the motor contactor. So take the output of the motor contactor, X3 and X4, and connect them to the motor. So now we have a power supply feeding the button, which actuates on the motor contactor. We have the motor connected to the contactor. Now the last thing we need to do is to connect the axis of this conveyor to the axis of the motor. And now we have everything connected. What's the benefit of doing this way, even if it sounds like quite hard work, is that actually you are teaching how everything works in reality. This is actually what you need to do if you want to build this system in reality. You need to use the same component. You need to wire them exactly as I did. And now let's add something to this conveyor so we can actually see if it moves. So I'm gonna add a box. We are gonna put it here in the center of the conveyor. Click play. The box is gonna fall down. And now if I did everything well, while the button is pressed, and you see that I can click it to press it and click back to release it because it's a maintain button, the conveyor moves forward. And when it comes to the end, the boxes will fall down because all this is happening because of the physics engine behind the scenes. So at any time I can reset this and then click play again. Everything is gonna go to home state or home position or initial state, and then I can keep playing and make sure that everything is working well. If I miss one of the connections, like for example if I remove this connection, this wire from the power supply to the button, I can actually replicate a problem or a fault in this system. So now anything is gonna happen or nothing is gonna happen, and I can at any time make the connection back, and now when I click here it should work. Actually I can see the values of each port when I click on the eyes. So while the button is pressed, you see X2 has 24 volts as the input one, and when I press it, and when I release it, it's 0. So this is how you build and how you make sure it works. Again, this is just a system we build. How you want to use it in your course, it depends which is the learning outcome you are looking for. Is it that you want the students to be able to troubleshoot the system? You want the students to be able to build the system? depending on that, you will give them, see, we prepare the system already connected completely, or maybe missing some connections, or maybe without any connections, so they need to figure out how to connect everything. And just very quickly, I'm gonna we already did some pneumatic connections, but just to illustrate that it's good to group the components in different assemblies, I'm gonna add just another group. I'm gonna call it pneumatics, and in this group, which I'm gonna move away, I'm gonna add just the cylinder we had selected before, which is here. Let's call it cylinder 01, a bulb. We have this nice 3-tube bulb. And now what we basically need, as you saw before, we need to connect the compressor to the bulb and the bulb to the cylinder to make it move. But in this case, it's a solenoid bulb, so we need something bringing 24 volts to the solenoid, so we can activate the valve and extend the cylinder. So what we are gonna do is gonna take this button we had here, we are gonna duplicate it. It's gonna create a copy exactly in the same place as the previous one. You see it here. Now we are gonna move it to the new group or the pneumatics group, and now we are gonna bring it here and we are gonna rename it. We are gonna call it button 2. Let's quickly do the connections we need to do. Basically quite similar to what we did before. We are going to connect the power supply to the button, and we come to the bulb, connect the compressor. We bring 24 volts from the button to the solenoid, so we connect the output of the button here in to the X11, and then we connect the power supply 0 to the X12. And now we just need to connect the cylinder to the bulb. So now if everything is okay, we should be able to press the button, and while the button is pressed, the cylinder extends because it's a single acting cylinder. When we release the button, the cylinder goes back. Again, if we miss any of the connections, for example, I removed the connection between the bulb and the cylinder, this pipe, if I press the button, nothing will happen. Okay, I can recover the connection at any time. I can come back here, take the bulb, connect it again, and now it should work. So those are the basics. That is how you build. And now, just to move forward quicker for the next experiment, I'm gonna close this. Let's save it first. So I show you as well as before that you just save this, take a picture as if you want to just leave it like that for your students, make a capture like that, and now this system is ready for whoever wants to play with it. Let's close it, and I'm gonna open now just the system that is kind of the evolution of what we basically built. So now we have almost the same elements, but arranged in a different way. I copy, duplicated some components, and what we have here is a system where we can drop a box. With this button I can activate the conveyor. With this button I can activate the cylinder, so when the box comes forward I can click this cylinder, then I can click this, and the box is gonna fall down here at the end of the second conveyor. So kind of more fun here. The students can see things happening. You can see what happens when the box comes to the end and falls and so on. It makes all this teaching more fun and gamified somehow. So I promise it's changed a lot the way of teaching and how the students learn all these basic principles in pneumatics or electricity or whatever. But now we are going to take this system that, as you see, is completely manual. We have some sensors that are not connected to anything, and we are going to add a PLC, and I'm going to show you how you actually can automate this pretty easily, so you can take it to the next level. You can build a system and teach PLC programming to your students, but using the same tools that you are using right now. Okay, so let's open we have here codices. This is what we are gonna use. I like codices because of this simplicity, and it actually comes with a soft PLC, so we don't really need a real PLC to test this. But again, it's not Simumatik where you are gonna program it. We don't want to replace the tools you're using for teaching PLC programming in this case. We are gonna connect Simumatik to your PLC software. In this case, as you're gonna see, using OPC UI, so it's quite open. It covers almost all the PLCs in the market, and you will be teaching the same thing that you have been teaching until now, but you are able to use virtual labs instead of being limited to your physical labs, or maybe not lab at all, nor physical equipment at all. So how are we gonna change this? Pretty easy. We're just gonna add here another component, and it's gonna be a component. This one is a OPC UI PLC. Let's call it just PLC. And what we are gonna do now is this PLC has 8 inputs and 8 outputs. So what we are gonna do, we are gonna power it. Let's connect it to the power supply very quickly, so it can start working. And this PLC is gonna try to connect to a real PLC. So this virtual PLC component is gonna try to connect to a real PLC, or in this case to this soft PLC that comes with codices, where I'm gonna download the program, and it's gonna fake to that PLC, so it thinks it's connected to real sensors and real equipment. So your code will execute as it will do in using a real system. So what we need to do is that now we need to connect inputs and outputs to this PLC. So the same way we have been connecting components to each other, now we need to take all these sensors we have here and their signal and connect them to the PLC. So very quickly we go to the conveyors and take each of the sensor signal and we connect them to the first 4 PLC inputs, okay, regular digital inputs. So now we have taken a cable from the throw a cable from the sensors to the PLC digital input. And what we need to do now is take these outputs and connect them to these motor contactors and the solenoid valve. So let's remove all these buttons that were doing the work before. So we can remove that button, we remove this button, and even this last one. And now let's come to the contactor and let's connect this to the first PLC output. Let's connect this one to the second PLC output. Now we take this valve, the first one used as an elevator, or with this cylinder as an elevator. We connect it to the port 2 and this last one to port 3. So now we have the same equipment we had before, but just did some changes. So now we have everything connected to the PLC. And what we are gonna do now is just using codices, we are gonna control the system, okay? How we do that, as if you didn't realize, here we have just 2 variables in Simumatik, which will be where the Simumatik is gonna write and read the input and outputs, okay? So I already prepared the project in codices. We have tutorials for that, so just check here in the help button. So it will guide you which are the simple steps that you need to set up the project in codices. But basically what I did is that I create those 2 variables, input and output. They are bytes, 8 input and 8 outputs, and then I map the sensors exactly. I knew how I need to connect them, so I map the 4 sensors and the 2 contactors and valves to the outputs and inputs. So everything is basically set up, and I actually prepare a simple SFC program. The limitation of the language is not in Simumatik. Again, we are using codices, so you use the language you want and you program the logic as you prefer. So this simple sequence is gonna try to move the box forward until the end, but actually I already have programmed everything. Let me remove some steps here, so we see just part of it. So let's stop the sequence here. So how does it work? We just need to make sure we have a PLC that Simumatik can connect with. So I just started the soft PLC here, just download the program. So now we have this logic inside the PLC. Let's start it and now activate what we call the gateway, or what is called the gateway. This is basically the bridge between Simumatik and any other third-party hardware or software. Okay, it's like magic, we could say, but basically once the gateway is connected and you click play, the components that want to talk to other software or hardware, they will do it by itself. Okay, you don't need to care much more than that. So basically I click play, we wait some seconds, and if everything is okay, we should see this happening. So the PLC is running now, and actually the box fall down and came all the way to the end of the conveyor. Let's remove the box as it is now, and I'm gonna add what we call product entry, so we can actually decide when we want to introduce a new product. We click here in the system, add a new product entry, and what we are gonna say here is that we don't want to automatically drop product. We just set 0 here, but we want to this element to drop just this kind of products, these mini boxes. You can add more than one type of product. Select if you want to have random or sequential drop, so you can introduce to your system the products in the way you want to test your logic. So basically now if I click play and I right click here, I can drop a product, and then oh sorry, I didn't move the product entry. So let's bring it here on top of the conveyor. There it should be. So now I can drop a product, and we see that because the sequence is in this step here, the conveyor is all the time moving forward. Let's now restart the sequence. We do a cold warm. We start with the initial step, click play. You see nothing is happening here until we drop a product, and then you see how the sequence evolves. Okay, so if we want to finish this sequence, basically going back to what I had before, we just need to add all the signals we have coming from the model and just write the sequence. So what we want to do here, we want to move the conveyor forward until first sensor is detecting, then we add we activate the first valve. Let's do like that. When the valve moves up, this second sensor will detect the box, so let's do like this. And when this happens, what we want to do is that we want to activate keep the first elevator valve open, so the box doesn't fall down, and actually activate as well the second valve. So now we're pushing the box to the next conveyor, and now we can just activate the motor contactor in the second conveyor and wait until the sensor or the box arrives to the end, and that will be basically all. So let's fix this. We'll add here just a few seconds of delay. Let's add a couple of seconds, so we make sure the box ends in the or is pushed to the second conveyor. Let's reset the model. Let me see if we can move this a little bit like that. So we click on play, reset the sequence, so we start from the very beginning, click play, and you should see how now when we add the box, the sequence is being executed. We should see now the all the valves are activated, and after the delay of 2 seconds the box just moved forward until it was detected by this last sensor, and then the sequence started. So we could actually drop a new product and we will see that the same happens. So it's already 15 minutes to 7, so that was basically what I wanted to cover with this webinar when it comes to building the system and showing the opportunities. This is just some inspiration for you who are teaching. As you see, you can cover everything from very basic engineering or physics, pneumatics, hydraulics, electricity, and go all the way to PLC programming, robotics, and if you are interested, we can share with you a lot of experience we have with more advanced programs. We are looking all the time to connect Simumatik through the gateway to new software like MATLAB or other programming software. So don't hesitate to contact us if you wonder, or just write us some comments now so we can answer them. And yeah, so basically if you want to know more about us, I will recommend you to just navigate to simumatik.com. I'm gonna share the screen again with you, and you can anytime contact us and send your questions or your anything you wonder. Book a demo if you want. Here in the top right corner you can actually book a demo with our engineering team. They will show you or demonstrate the capabilities of the platform, or maybe discuss how it can be adapted to your organization or your needs as a teacher. And yeah, so just we are here for help you. So let's we have now around 10 minutes to just answer some questions. So let's see what we have here. Jerai is asking if the gateway is already part of the web app or how does it work. Okay, yeah, I was showing that you just click here and you activate the gateway or deactivate it. It's actually the only piece of the platform, the Simumatik platform, that is actually totally required to be downloaded if you want to connect the models to third-party hardware or software like a PLC. So if you click here, you will be asked to download it if you don't have it installed, or when you are disconnected, you will see also that it will tell you if you want to download it if it's not the latest version. So actually, if you want to know more about the gateway, it's an open source tool. So we actually want to open up the opportunities of connecting Simumatik to third-party hardware and software. So any user is actually free to develop their own communication drivers to connect to whatever you can imagine. So that is also if you are interested in those possibilities, just don't hesitate to check our GitHub account or ask us using our contact form. Let's see. Yeah, here we have Kate asking how you can delete different components at the same time. Right now you can just delete them separately like this, remove them, or you can clean up the entire group together. If you want to delete several elements in the same assembly but not the entire assembly, then you need to do it individually, one by one. Okay, do we have any other question? Let me see. No. Okay, so if there is no more questions, just thank you everyone for watching this webinar. Again, we are here if you have any question. And feel free to ask, check our tutorials. You know that You have a free month to try the platform. If you have any, you want the opportunities we have, so feel free to create an account, jump into the tutorials and check what is possible to do with the Simumatik. We have another question here, 2 questions. Yeah, here we have a question from Jean asking if you can upload your own components or your own 3D models. Yeah, actually, we haven't covered anything about creating your own component. This will be enough for its own webinar. We probably will have that in the near future. When you create your component, you actually usually start bringing the 3D part of that component and then bringing it to life. So yes, the answer is this. You usually take your CAD models. We have a we usually recommend to make some simplifications and so on. You convert it to the format that Simumatik supports, GLB, which is quite optimized for video games and these kind of tools. And then you just add other aspects like physics, the behavior, and everything else, and define the ports and so on. So you actually create this individual component that you can reuse in many other in many systems. And actually, if you want, you can also share it with the rest of the community. Yeah, another question here from Jerai. What's the physics engine used for? Yeah, the physics engine does a lot of work for free. So, for example, something very easy to demonstrate what the physics engine does is just to set up here period for dropping the components. So what we will see now is that once I click play, the components are gonna stop dropping one by one. And what you don't need to think about with Simumatik is that, oh, sorry, I didn't change the screen. So what you don't need to do with, what you don't need to care about is what happens when components crash or products crash with each other. So right now, the physics engine is taking care of that. If you activate the PLC in this case, and because the program is run, things are gonna crash, you don't need to think about it. The physics engine is going to provide that. Another question from Steve is if the pressure gauges are showing true pressure. Yeah, it's actually each port has is showing the values at the moment. So those pressure gauges that we were using in some of the videos are actually connected to the port like any other component and are showing the pressure that is flowing or the electricity that is flowing through those ports. So it depends on how you model each of the components, because you can actually make a pretty advanced and detailed model. So the pressure required to move, for example, a cylinder or extend a cylinder and the flow that will generate and so on, you can actually add those this mathematical equation inside the component, so you actually can have pretty accurate readings or pretty accurate simulations of what will happen as well in the reality. And this is something also quite unique in Simumatik, because we have developed the platform thinking that the components can transfer energy in different ways, not just electricity or pressure between each other, just to even allow selecting the proper components or dimensioning the components according to your application. So this is something that we also have collaboration with some universities where they do research on optimizing energy consumption of the system because of this possibility that Simumatik brings. So yeah, let's wait just 1 second or 1 minute or two, and if there is no more questions, I think we can be finishing now. So yeah, thank you everyone, and I hope you enjoy the webinar. If you have any suggestion for other webinars or comments, send us an email or just write any comment now after we close. And yeah, have a nice evening.